Hello, today we're just going a little bit further with the Pythagorean theorem. Instead of just calculating sides, we're going to look at a few ways that we can apply the Pythagorean theorem just to solving different situations. But first, we have two examples here of just looking at what the Pythagorean theorem does. So if we remind ourselves what the Pythagorean theorem is, it just tells us that the sum of the squares of the sides of a right triangle equal the square of the hypotenuse. So if I square each of the short sides, then that sum, and add them together, that sum should equal the square of the long side. So we can use the Pythagorean theorem, a squared plus b squared equals c squared, to solve for these missing values. So if I look at this first problem, x is the long side, so that's the hypotenuse. So if I want to solve for that, I would add the other two sides together. So I would take 1.5 squared plus 2 squared, and if I add those together, I should get x, the unknown side, squared. So I just go through, and like I said, sometimes if you don't know these off the top of your head, you can use a calculator. I know that 15 squared is 225, so 1.5 squared is 2.25. When I add that to 4, I get 6.25, and I remember that the square root of 625 is 25, so I can get this answer of 2.5. They were trying to be nice, but don't worry, you can use a calculator for these also. So my answer is x equals 2.5. I should have added in inches because there's inches here and inches up here, so it is 2.5 inches. And so I just applied the Pythagorean theorem. I added the two sides that are touching the right angle. I squared them, added them together, and that gave me the square of my unknown. Sometimes it's not the hypotenuse that's unknown. Sometimes it's one of the sides. So if I look here, my long side, I already know, right? The opposite of the right triangle, that's 7 meters. I already know that number. What I don't know is one of my sides. But I can still apply the Pythagorean theorem. I just have to put the variables in the right places. So if I look here, I have x squared because that's a side. So it's like a, it's x squared plus 4 squared. My two sides equals the square of the hypotenuse, 7. And just like before, I'm just going to go ahead and rearrange it. X squared equals 7 squared minus 4 squared. I moved it to the other side. I calculate my squares. 49 minus 16 equals 33. I don't know what the square root of 33 is, but it's okay to just leave it written like this. X equals the square root of 33. If I wanted to, I could get out a calculator and figure out this number to the nearest tenth, but it's okay also to just leave the answer written like this. So this is what we were doing yesterday. We've been practicing the Pythagorean theorem. But today we want to talk about what are some other things we can do with the Pythagorean theorem. And there's two in particular that we're going to talk about, two other things that we can do. One of them is called the converse, right? And the converse is just kind of an opposite, right? It's a turning it around. So in the Pythagorean theorem, it says, if I have a right triangle, then a squared plus b squared equals c squared. If I turn that around, like I look at it in a mirror, it says, well, if a squared plus b squared equals c squared, then this has to be a right triangle. So instead of knowing that it's a right triangle and so solving for a side, using the converse of the Pythagorean theorem, I can say, if I can calculate from the sides that a squared plus b squared equals c squared, then I know that it's a right triangle. So let's look at how we would apply that. Okay. Here are some triangles. You'll notice there's no right angle symbol. I don't know if this is a right triangle, but I do know how long each of the sides are. So I can use the converse of the Pythagorean theorem to check it. Is that a right triangle? Well, these are clearly my short sides, 9 and 40. They're both shorter than 41. So if a squared plus b squared equals c squared, then I know it is a right triangle. So 9 squared plus 40 squared, Does that equal 41 squared? And you see I have this equal sign with a question mark. Are they equal? I don't know. That's what I'm checking for. So 9 squared is 81, 40 squared is 1600. If I add them, I get 1681. As it turns out, 41 squared is 1681. So yes, this is a right triangle. So I can just say, yes, that is a right triangle. I could even just draw the little right triangle symbol in. But what about over on this other one? 18, 12, and 24. I see that 24 is the longest side, so that one's where I'll put my hypotenuse. Is it true that those give me a right triangle also? If I were to use this formula, would I get a right triangle for this one? So I can go through and fill in these numbers, and I have a squared and b squared. Remember, they're always going to be the two shorter. The longest side goes alone. So 18 squared plus 12 squared, does that equal 24 squared? 18 squared is 324, 12 squared is 144. Remember, I just put these in a calculator. 324 plus 144 equals 468. But 24 squared is 576. They're not the same. So this is not a right triangle. No, it's not. I won't put the symbol there because it's not a right triangle. So remember, this is just the converse. I plug in the numbers and find out if it's true. If it's not true, then it's not a right triangle. Okay. Sometimes you don't get the picture. They just give you the numbers. But remember, the longest side is always the hypotenuse. Here I could see, this is the longest side. It's opposite to the wide angle, so I could see that. On these ones, I don't have the picture, but I do know that the longest side is always the one that's going to be alone. It's going to be on the C. So I can go here and just plug it in like I did before. I just take the two shorter sides, 21 squared plus 20 squared. Does that equal 28 squared? And again, I have this question mark because I don't know. Is it true? Well, I go ahead, plug it into my calculator. 21 squared is 441. 20 squared is 400. Together that equals 841. But when I put 28 squared in my calculator, it gave me 784. These two aren't equal, so the answer to this question is no. This is not a right triangle. So that's one way that we can apply the Pythagorean theorem, just to calculate is something a right triangle or not. Another way that we can use the Pythagorean theorem, and this is actually a very useful formula that'll come up again and again, is just the distance formula is what it's called. And you see, if I have these 2 points, x1, y1, and x2, y2, I want to know how far apart are they. Well, I know that I can calculate how much higher it is by looking at the distance in the y's, and I can calculate how much side to side it is by looking at the distance in the x's. But that doesn't tell me exactly how far apart they are. However, now I can look at it and see, well, this definitely makes a right triangle. And I know for any right triangle that a squared plus b squared has to equal c squared. So they've just rewritten that to solve for d by taking the square root of a squared plus b squared. And this is just the derivation of the distance formula. When you're applying these formulas, it doesn't matter which one you call 1 and which one you call 2, as long as they stay in the same order, right? If the lower x goes first, then the lower y has to go first. It doesn't matter what order it is, as long as you're using them in the same order. So here's just an example that we can do. Find the distance between 1, 5 and -4, -2. So I copied out the distance formula, right? X2 minus x1 squared. All right, I just took a second there to fix all my subscripts so they're easier to see what's going on. So x2 minus x1 squared plus y2 minus y1 squared. This is just exactly the formula that was on the page before, right? I'm just going to go ahead and stretch this out over there to make it easy. And like I said, it doesn't matter which one I do as 2 or which one I do as 1, as long as I keep them in the same order. So for this problem, I went ahead and called this point the point 2 and this point the point 1. So you can see I plugged in x2 minus x1 and y2 here minus y1 right here. So minus 4 minus 1 is minus 5. And that's okay. I can have a minus sign. I can square something that's negative. That's not a problem at all. Minus 2 minus 5 gives me minus 7. I can square something that's negative. That's not a problem. Anything that's negative, when you multiply it times itself, you will get a positive number. So minus 5 squared is 25. Minus 7 squared is 49. So together that is 74. I don't know what the square root of 74 is. So I actually could leave my answer just like this. D equals the square root of 74. But if I put it in the calculator, I could get D is approximately equal to 8.6. So it's just the distance formula. You apply it just like that. Again, it doesn't matter which one is 1 or 2 as long as you use them in the same order. You just have the square roots. And the converse of the Pythagorean theorem we looked at here. If this statement is true, then it is a right triangle. So there's some practice questions that you can look at, and if you have questions, you come to the meeting, send an email. We're happy to answer them whenever we can.